Hello everyone. So in this experiment we're going to see about which is the experiment fifth, which is the topic is called multi-layer perceptron. So I will show you the explanation and I will implement this multi-layer perceptron model uh, using PyTorch to classify the breast cancer dataset. So first, what we are doing is that we import the necessary libraries. In the libraries as Torch, PyTorch for building the neural networks in order to implement the multi-layer perceptron, and NumPy for mathematical operations, Matplotlib for visualization, and sklearn modules for data pre-processing and evaluation. So what are we doing now? We're just loading the data set from Scala. What did we just do? We just imported here from data sets import breast cancer. So we're loading the data set of breast cancer. And what we're doing is the independent variable X here is stored here, which contains features like tumor measurements, like 0 for malignant tumor or 1 for benign tumor. And next we standardize the data using standard scalar function. We ensure that the data set is normalized where the mean is 0 and standard deviation as 1, which is very important because when the input data is normalized, the neural network models work better. Then we trust split it. So we give 80% as the training data set and 20% of the data as the testing data. And next we're converting it to PyTorch tensors. We are converting the input features as float tensor and target labels as long tensor. This is required for training the neural network. And then we're defining the multi-layer perceptron model, where we give the input layers, where we give the input size. So there are hidden layers, which is come to goes from 64 and then decreases to 32, and then from 32 to 16, 16 to 8, and 8 to 2. So there are totally 1 2 3 4 5 6 7 8, so 8 neurons are there as a hidden layer. An output layer is of 2 neurons, which is used for classification. So we are using RELU activation function for each hidden layer. So this introduces non-linearity of the model. Then we're going to train the model. So we train the model using a cross entropy loss as the loss function, and atom optimizer for updating the weights. At during training, the loss is calculated and the back propagation updates weight, and it is repeated for 100 epochs. And then we plot the training curve, like for x-axis we take the number of iterations, and for the y label we take the training error, and we titling it as training curve. So the graph shows that the training error decreases over time, such that the multi-layer perceptron model is learning. And then we're just testing the model. And finally we do a performance evaluation like confusion matrix, accuracy, overall correctness, how much is the accuracy. So as you can see here, confusion matrix is visible over here, and accuracy is 0.9824, and the precision is also calculated to predict predict the positivities of correctness, and then recall to detect the positives, and finally the F1 score to balance precision between and recall. So that's it for this experiment. Thank you.